Hi everyone. Now we are going to discuss about one of the fascinating topic in the area of special theory of relativity. It is time dilation. So we are going to discuss about the topic of time dilation with the two specific examples. One is moving clock and another one is twin paradox method. Okay. Just think about the first example of a moving clock. You just have an arrangement. You just imagine we have two mirrors. In between these two mirrors, a light start bounce back and forth. Whenever light reaches the one side of a mirror, we have a speaker connected with it. By means, we have a mechanism to get a beep sound. So, if you say the distance between these two mirrors will be d, then what about the time taken by the light to bounce back from the mirrors will be given by the term distance by the velocity of the light. So this one is very common if you want to do the calculation for a stationary mirrors. You just think about now a moving clock. On the initial stage, a moving beam is on this position and then it just start moving. If the mirrors are moving on the x-axis, so you just notice that whenever the beam is going to reach higher position, otherwise the upper mirror, so distance traveled by the beam will be velocity of light into delta t. So delta t is the difference due to the moving clock. Likewise, once the light beam start back to the mirror on the lower side, so again you just notice that there is an increasing in the length of the light beam is achieved because of the moving frame of the mirror. Using our Pythagorean theorem, you can notice about what about the distance traveled by the beam with respect to the velocity. You just notice that there should be some increasing in distance time taken is announced. So that to be named as time dilation. So just time dilation simply represented on relativity. We have a chance of increasing in time is expected, otherwise time is slower if we consider with a moving frame. Right. Now we are just going to explain this concept with the twin paradox method. You just think about an example. We have twin brothers and sisters. So between these two we have well twins, so have same age. So we are just allowing the girl to reach Alpha Centauri, the nearest star to our solar system. So as of calculations, it may take at least 4.3 years to reach the Alpha Centauri if we use a space rocket of having velocity of 0.9 to otherwise you say it is 90% of the velocity of light. So you just notice that I will just infer that the boy stays on home, whereas the girl, our twin sister, start going to Alpha Centauri. So she take a space rocket and just start moving to the Alpha Centauri. So whenever clocks are started on both Earth and the spacecraft, we just know the calculation as per the velocity of the spaceship is around 90% of the velocity of light. Then she may reach the Alpha Centauri within 4.3 light years, and then according to the boy on his clock on Earth, the time taken by the twin sister to reach the Alpha Centauri will be 4.8 years, and then again she is trying to come back to Earth again. By means that the same calculation, what much of time taken to return back will be again 4.8 years. So according to the boy's clock on Earth, it takes at least 9.6 years that his twin sister reach the Alpha Centauri and try to come back. Whereas if with respect to the girl's clock, how much time he take? Just imagine that T out, how much of time taken to reach there with respect to the relativity constant. So according to the boy on a clock runs slower, by means that it may reach the Alpha Centauri by 2.1 years, whereas return also will be taken within 2.1 years. By means that according to the clock of the girl, the boy noticed that within 4.2 years the girl come back to Earth again. So according to the clock of the boy and girl, you just notice that the difference will be high. So you just imagine the Earth is the stationary, whereas the twin sister is moving on the space rocket. So by means that there is a contraction will be there. So this calculation says that she ages less when she goes and come back with the velocity of 0.9 of velocity of light through a space rocket, whereas her brother is aged high. Okay, so according to this calculation, you just notice that whenever she starts saying about it is totally different with respect to the clock what she observes with respect to the boy's clock on the Earth. According to her clock, the boy's clock on the Earth says that within 1.8 years she has came back. by means that what she noted is her clock advances 4.2 years, whereas she sees his clock advances only by 1.8 years. So she should think he has aged less than her, and then it leads with a contradiction. So this contradiction is happen in boys' life and girls' life also. So just notice, when the twin brother allows her sister to reach the alpha century, it takes at least 4.8 years to reach there. Then as per girls' clock, it is taken by only 0.9 years to reach the alpha century. Whereas after reaching of alpha century, try to come back in a short of time, because of the two flames are at rest. So there is no chance of time to be allowed. So she feels without any time delay, she turned back to Earth. And then after 4.8 years, she reaches the Earth again. So that time she noticed that her brother ages old while comparing to her. So this is to be termed as time dilation. So the concept of this time dilation is to be leads with time interval between the two events depend on the state of motion of the observer. So this is one of the important topic in the field of special theory of relativity. Thank you.